Do you remember at the beginning of the year when I said that geometry can help you win arguments? We are starting to get into that part of geometry right now. So this is pretty exciting. A lot of times when people hear the word proof, they get scared. But I don't think that's a necessary response at all. So when you hear proof, it just means defend your answer, which you guys have been doing for years. If you took pre-algebra, algebra 2, whether you took that or not, you've been defending your answers since then. So we're going to start out with some algebraic proofs because everyone has passed Algebra 1. So I'm just going to relate it back to Algebra 1 with something that you're familiar with before we dive into new geometric ones. So in algebra, you may remember when you solve equations, there's a do-do rule. For example, if you are solving an equation that looks like this, a minus 2 equals 5, to solve that equation, you need to add 2 to both sides. It's a do-do rule because if you do it to one side, you have to also do it to the other side. That's all the addition property of equality is saying. You just add the same thing to both sides. So you can see we're adding a c to both sides. The same thing works for subtraction. So if we started out with a plus 2 equals 5, you would have to subtract 2 to both sides in order to get this to work. So your subtraction property of equality is just subtracting the same thing from both sides. Okay, the same thing works with multiplication. Here we're just multiplying c to both sides. And division. Here we're just dividing c to both sides. Okay, substitution is also something that we cover a lot in pre-algebra and algebra. So it's just saying that if A and B are the same thing, they can be substituted for each other in any situation. And the last property that I added on here from algebra is your distributive property. So that says when you have something on the outside of the parentheses, you distribute it by multiplying it to everything in there. Some other properties that we'll be using that you may not have heard of before are listed here. So the first is a reflexive property. So when I think reflexive, I think reflection, looking in the mirror. When you look in the mirror, you see what you look like to other people. And that looks the same as yourself. Okay, so the reflexive property of equality is the same thing on both sides. So notice on the left side, we have AB. On the right side, we have AB. It's exactly the same thing on both sides. And this can work for a segment or an angle. So with the angle, it's the measure of angle A and the measure of angle A. So it's exactly the same thing on both sides. Your symmetric property then, remember symmetric property, if you're talking about symmetry, say you have a shape. If I could draw correctly, then we would say it's symmetric because if we fold it in half, it would match up. Now again, I was not able to draw that perfectly, so it's not quite symmetric. But it's the same thing on both sides, you fold it over. So in this setup here, if we take this and folded it on top of itself, then the CD would switch sides and the AB would switch sides. Okay, so it's the same exact statement, you're just switching what is on what side. So the left comes to the right comes to the left. And again, this works for a segment and also an angle. So we're just taking the measure of A, measure B, and we're switching what sides they're on to get this statement. Okay, that comes in handy if your proof statement is written in a certain way that you just need to switch the sides, you will use your symmetric property. Your transitive property, I think about a long train. So a train has multiple cars. So it's a transitive. Sometimes I call it transitive. Okay, so if this is a train car, and this is a train car, and this is a train car, they're all connected. We got our little smokestack because it's a steam engine. So transitive is the longest one. It has the most going on. This is similar to the law of syllogism that we discussed earlier. Okay, so you're taking two statements. You might notice that the end of the first and the beginning of the second is the same. So we're going to cancel out that repeated, just like we did with the law of syllogism in deductive reasoning. Okay, and again, the same thing works for angles. We have our first train car here, Second train car here. Third one's on a different line, but it's the same kind of setup. Okay, so you have a lot going on. And again, same thing happens where the end of the first and the beginning of the second are the same. So we're canceling out that repeated information, just like we did with the law of syllogism. So I want to walk you through a couple examples of what this looks like using the algebraic properties. So every single proof that we have, there is a given, which hopefully you can see here, and there is a proof. A lot of times there will be the word given and the word proof. Sometimes there won't, but you'll still be given some information and asked to show something. Okay, so for our purposes, our proofs this year are all going to be 2-column proofs. The statements go on the left, and the reasons go on the right. So 2 columns, one for your reasons, one for your statement. You always, always, always start with your given information. So again, this is your given information here. So we're given this equation, 3x minus 4 equals negative 13. The reason we know that information is because it was given to you. So your first reason should always be given in every single proof that we do. So we're reviewing algebraic properties here. So if I were solving this equation, the first thing I would do is I would add 4 to both sides of this equation. So my second statement is going to be what I have once I do that. So negative 13 plus 4 is negative 9. Well, what did I do to get that? I added 4 to both sides. So this is our addition property of equality. Notice I'm abbreviating some of these words. That is totally okay. So then the third thing is what I would have to do next. So in order to get excellent, if I was solving this, I would need to divide both sides by 3. So my statement is what is left over when I get that, x equals negative 3. And what I did to do that, I divided both sides by 3. So this would be the division property of equality. Now, if you look at my third statement, right here, that is the exact same thing that we are asked to prove up here. So once your proof at the top matches your proof at the bottom, your proof is done. So this proof is completely complete. This is an example of an algebraic proof that does not come right out with the words given and prove, but it's the same sort of situation. So when you exercise, your target heart rate should be between 15 to 70% of your maximum heart rate. Your target heart rate R at 70% can be determined by the formula. R equals 0.70 times the quantity of 220 minus A, where A represents your age in years. Solve the formula for A. So again, the word given is not here. The word prove is not here. But we can easily see what we are given and what we're being asked to prove. So in our 2-column proof, statements always goes on the left, reason always goes on the right. My first statement is this formula. So I'm going to take that and put it down here. 0.70 times the quantity 220 minus A. Well, where did that formula come from? It was given to us. So again, reason number 1 should always, 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 always be given. So now we're going to go ahead through and solve this. Okay, so I'm going to go ahead and distribute here. So because I distributed, my reasoning would be the distributive property of equality. And again, it is okay to abbreviate as long as it's still obvious what your reason is. So you don't want to abbreviate like D, that's not a D. You don't want to abbreviate DPOE, that's not enough information. So make sure you're not doing that much abbreviating. But distr is going to be distributive, prop is going to be property of EQ is going to be equality. Your other option for abbreviating here, all of these properties of equality, you could also just write distr for distributive. You can write POE, P-O-E. That's going to mean property of equality as well. So that's another option for your abbreviation. I'll leave that up to you. So now we got to keep going. So the next thing I'm going to do, we are trying to solve for A. So I'm going to subtract my 154 from both sides. So what I'm left with is r minus 154 equals negative 0.70a. Well, how did I do that? I subtracted. So this is going to be our subtraction property of equality. Now with subtraction, you do need more than just sub for your abbreviation, because substitution is a property as well. So make sure you have this TR as well, so we know it's subtraction and not substitution. So we're going to keep going on. Notice that I number my statements and my reasons, so it's very obvious what reason goes with what statement. Now, in order to get a alone, I need to divide by negative 0.70. I'm going to do that to both sides. So what I'm left with is r minus 154 all over negative 0.70. And over here, those cancel, leaving me with a. How did I do that? I divided. So this would be your division property of equality. Now, again, the word prove is not here, so we're not entirely sure, like it's not written out clearly for us where we can stop. But because up here it says solve for a, you have a by itself right here. So you have done your job. You've proven what they wanted proven. So this is now finished. Now that we've done two algebraic proofs, I kind of want to preview what a geometric proof could look like for you. So there is a diagram here. And it says in the diagram, the measure of angle ABD equals the measure of angle CBE. So this is something that I'm going to want to mark in my diagram right away before I even get into my proof. So remember, to mark that angles are congruent or equal, you put an arc in there. So ABD, follow those around, ABD, that's this whole angle here. And CBE is this whole angle here. So it's a little bit tricky because they overlap a little bit, but hopefully you can see with the colors where I'm getting that. So now that I have that, I'm going to go ahead, I'm going to set up my proof. So my statements go on the left. My reasons go on the right. And reason number one is always going to be given. Okay, and that was given up above here. The measure of angle ABD equals the measure of angle CBE. So you're just copying that. So even if you know nothing else, you should always have statement number one, reason number one, always. Okay. Now they are giving us a proof here. They're telling us to show that the measure of angle 1 equals the measure of angle 3. So that is the same thing as what you're being asked to prove. So that means your very last step, we're not quite sure how many steps it's going to take to get there, so I'm not going to number it. But our very end to our proof should be the measure of angle 1 equal to the measure of angle 3. Again, I did not number it yet because I'm not sure how many steps it's going to take to get there. So the measure of ABD, if we're looking back up at statement number 1, notice when I drew this on the diagram, it covered angle 1 and angle 2. So that's kind of where I'm going to go next. I'm going to say the measure of angle 1 plus the measure of angle 2. That's what gave me ABD. Okay, well, how did I know that? We have a postulate that says if you add the two smaller angles, which in this case would be angle 1 and 2, it's going to give you the larger angle, in this case ABD. So my reason here is your angle addition postulate. So that's something that we learned earlier in the year, but all those postulates and definitions we've already learned are fair game in these geometric proofs. Now I'm also going to do the same thing for the measure of angle CBE. So when we outlined that, we saw that this spanned over two angles as well. In this case, it was the measure of angle 2 plus the measure of angle 3. That gave us CBE. Reasoning would be the same because you're adding the two smaller angles to get the big ones. This is still angle addition postulate. Okay. So now you kind of want to look at what you have already in the proof and if you can combine it at all. So you might notice here that measure of ABD equals the measure of CBE. Well, I've got ABD here and CBE here. I know that they have to be equal, but I also know ABD equals the measure of 1 plus measure of 2 from statement 2. And I know the measure of angle CBE from statement 3 is equal to the measure of angle 2 plus the measure of angle 3. So I can actually combine those statements. So I'm going to use statements 2 and 3 and combine them into statement 1. So statement 1 started with the measure of angle ABD. Well, instead of that, I'm going to substitute in the measure of angle 1 plus the measure of angle 2. Still looking at statement 1, we said that it was equal, so I brought the equal sign down, to CBE. Well, instead of CBE, I'm going to substitute in the measure of angle 2 plus the measure of angle 3. So my reason here is substitution, property of equality. Okay, because again, let me refresh here. Instead of the measure of ABD here, I substituted in this information because that's the same as ABD. Okay, and instead of CBE here, I substituted in this information because that was equal to the measure of CBE. There's a bunch of substitution. So now I want you to kind of think back to algebraic proofs. If you think about statement 4 as an equation, you might notice that if I subtract the measure of angle 2 here, got to do it to both sides, it's going to cancel on both sides. So what that then leaves me with is the measure of angle 1 equals the measure of angle 3. Well, that's what they wanted us to prove. That's the same thing that was our end game. And to get there, we subtracted. So this reason, 5, would be your subtraction property of equality. And then your proof is done because we said this was our end game, which is what we just got. So that's an example of one of the geometric proofs we might be doing in the future.